Well, here what we have going on here is a demonstration of a coil I made. This is part of a series of videos for the Paperclip DC motor that I'm going to build. There's a story behind that. I will spare that for another video. But so this here is the finished product what I made last night, and I'm going to demonstrate that for you now. It is made out of a sewing machine bobbin. This is a plastic bobbin. I got 10 of these for 99 cents on eBay China. So this here is a screw that I used some masking tape and then some electrical tape, and I just kind of forced that on there, and then you'll insert this end, the screw threaded end, into a drill chuck and lay the drill sideways, and then this would spin. And this is the wire here that I got out of an automotive relay. I worked at an Infinity dealer parts department, and this was warrantied out. So I cracked the case on that little relay, black plastic thing with some spade terminals coming out of it, and inside was this magnet wire. This is wire that has a thin plastic coating on it, and you burn that off with a lighter, and then you're able to apply voltage where the insulation has been burned off. And the trick with that is taking a hobby knife and scraping the burnt residue of the plastic off. I found that I was having a hard time getting a good connection on this wire unless I scraped the black residue off, and then I was able to make a connection. So yeah, you make yourself this piece here, put that in the drill, put the drill on low and have the drill spin, and then you move the wire back and forth as it completely fills up this spindle, and you end up with this coil. Now this coil ohms out to 28.5 ohms, which on the video of the guy who built this, he said you're supposed to have it around under 30, like he was shooting for 27 to 30. His was 31 and it worked fine. I was going for slightly lower because in his video he had gone over. He was at 30.1 or something, and he was like, oh, I wanted it to be a little lower. So I got mine at 28. And I did this, I tried a larger gauge wire. I broke a few wires by playing around. When I tried to remove it, I would break the wire. So what I found, the secret tricks for making this coil are to take an additional foot when you're coming out of here. If you put it through the hole as a slot, have at least an additional foot coming out, and then wrap that spare wire around the base here. So, and then as it comes up and you tape it around the chuck, and then strip some of that to take a measurement, because that's what I did. Then if that breaks off in between here, the chuck and the base, you still have that additional foot of wire wrapped around the turn. So that's how that worked out for me. I tried winding these coils a few times, successfully, unsuccessfully I should say, until I started getting the hang of it and being graceful, and having that spare foot wrapped around here is what ultimately did it for me. Learning that you can't just burn the wire, you have to scrape that off to make a proper contact to read the ohms. And then doing it, and somebody said 600 turns. Well, I wasn't able to have the attention span to count that. So I just kept doing it, and then I would be able to read off of the chuck. There was a part that was stripped with one of my meter probes, and then the other piece of wire coming off of this spool, you know, to set up, it would be like if you take this blue one here and imagine that it's there with the coil, and then this is on a screwdriver that's stuck through a piece of wood. This that went through the center of that allowed it to spin. A small, like, hobby screwdriver, something like this. I had a 2x4 sitting over here with a hole drilled in it that this type of screwdriver would go through to spool that out. And I would be holding the wire in between and moving it back and forth as it filled up the reel. So when I got to, you know, let's say it's about a half a dozen layers over, I would, in between, I would burn that incense, that what do you call it? Burn the plastic coating off of the wire here, and then use a hobby knife and lightly scrape the charred plastic off. Put 1 meter down here, and then the other meter up on the chuck, and get that reading between this coil of how many ohms. So the first reading that I took was 16, I ran another one up to 26, and then I gave it another 2 turns over, and that raised it up to from 26 to 28.5. So it almost seems like those 2 turns would be like one whole row over of this, which I think this is 44 gauge maybe. I don't know. On my digital micrometer, on my cheap, the one that people probably have, the Pittsburgh, this micrometer from Home Harbor Freight, the $11 one, it was coming out 0.13, the diameter of this wire. So with it going roughly with 2 turns, 2 solid runs across, that came out from, I checked it when it was 26 and it was 28.5. So 1 1/4 for a full turn. Ohms maybe is something that you could judge by. Pretty much you're going to have to hit and miss and do this until you get it right. But yeah. This is a demonstration video for the coil that I wound last night. It took me a few tries to get this right. There's some tips and tricks I would advise if you want to learn more about doing this to watch the other video that I made with the tips and tricks. So here's the 3mm by 3mm rare earth neodymium magnet. That was 10 of those I got for 99 cents on eBay. This here is a lithium ion battery pack that came out of something that I'm repurposing for my test. So I got the red wire hooked up to this white one here. The red wire coming out of the battery has a resistor. There's a 1K resistor, and I use this for testing LEDs as to see what color they are, or to make sure that they're not blown. So what we're going to do here is we're going to put this the nail that has the rare earth magnet on it. We're going to put that in this slot here of this coil, and let me get it off of this. Okay, so here we go. We're putting the magnet, and I'm going to make contact to complete the circuit here and see if we get any electromagnetic response. So let me check the voltage on and see how much actual voltage. I'm going to have to put the camera down for this second, so I apologize for putting. I'm using the multimeter now. What an awful video, huh? The probes are not really easy to get at. So here's the, I doubt you can read that. I doubt I can read it at this moment. Let's see how much voltage is in this battery, because I'm guessing it's around 4 volts. It's 3.4 volts. It looks like 3.49 volts. And the ohmage of this coil, I ohmed it out last night, so this is kind of pointless. 26.8 ohms, but I'm touching my fingers on both of the probes. This coil is under 30 ohms, and that was my target, and I'm able to make a reaction. I'm able to make the tail of the nail jump, and it doesn't pull it all the way through, but I'm believing 12 volts would do that, because this is only 3.5 volts. The point is that this coil works. Thanks for joining me, and there'll be more videos on this wonderful project as we go along.